Lecture 25 Inductor Basics. Why do we require an inductor? In a particular DC circuit, we can have voltage sources which supplies energy, we can have resistors which burns this energy, we can have capacitors which stores this energy in form of electrical field, and then we have inductors which stores this energy in form of magnetic field. So what is an inductor? It is simply a conducting wire wrapped around a particular magnetic material. For example, in this case, a copper wire is wound around an iron core. So this forms an inductor, and when this iron core is replaced by air, this forms an air core inductor. The symbol for the inductor is something like this, which is used in the electrical circuit. So how energy is stored in an inductor? When this inductor is connected across a voltage source, the current will start to flow, due to which magnetic fields will be established around this inductor. This magnetic fields can be visually seen like this. So this is an inductor and the current is flowing through this inductor. So the magnetic fields will be established, and these magnetic fields are concentric circles which are moving like this, and they are also permeating the magnetic material. So when the magnetic fields move through these magnetic materials, they create something known as core magnetic domain alignment. So what are magnetic domains? We have to understand first. So for that, first we need to understand that in an atom there is nucleus, and around it electrons are revolving, but electrons are also revolving around this own axis. And since electrons carry charge, so due to this revolution, they behave like currents revolving in tiny loops. Due to this current flowing in a loop, magnetic field will be produced perpendicular to this flow of current. In a material, there can be multiple electrons which are spinning in similar direction and producing magnetic fields in same upward directions. These areas where the magnetic field is in similar direction can be clubbed to form a magnetic domain. So this magnetic domain can be seen like this, where the magnetic field direction is upward. Now this is a more zoomed in version of this magnetic domains. So we can see that there are multiple magnetic domains inside a magnetic material, but these magnetic domains are not aligned in a particular direction. So what happens when the current flows through the coil? Due to this flow of current, there will be a magnetic field established around the coil, and this magnetic field will align all these magnetic domains in the similar direction. This can be seen from this image as well. Initially, the magnetic domains were randomly aligned, but due to the magnetic fields, these magnetic domains will be aligned in a particular direction. Due to this magnetic field alignment, the opposition to this flow of magnetic fields will reduce, and this opposition is basically called as magnetic reluctance. So magnetic reluctance will reduce, therefore stronger magnetic field lines will be established, and these magnetic field lines are the ones which stores the energy in the inductor. What does that mean? So once the magnetic fields are established and magnetic domains are aligned, and I try to change the flow of current, so in short I am trying to change the magnetic fields, then the original magnetic field alignment and the domain alignment will oppose this change in current. The property of the coil due to which it opposes this change in current is known as inductance. This can also be called as its ability to produce new flux. So the formula for inductance is simply L is equal to N phi divided by I, where N is the number of turns of the coil, phi is the magnetic flux produced, and I is the current flowing through the coil. Another formula for the inductance is L is equal to mu N square A by, where N is number of turns, A is now the area of cross section of the core, L is the length of the coil, and mu is the permeability of the coil. So what is permeability? It is the measure of how much material permits the formation of magnetic flux lines within it. So this means that higher the permeability, more easily will be the domain alignment, and therefore there will be stronger flux establishment, as a result of which there will be higher energy stored, and in turn there will be higher inductance. So this permeability is always established in relative terms. That means that this mu is simply mu r into mu naught, where mu naught is the permeability of the free space. That means that, for example, mu r of iron is 1000. So this means that Then iron core creates a magnetic field which is 1000 times more stronger than that created in air. And finally, the formula for energy stored in an inductor is simply half into Li square, where L is the inductance of that inductor and I is the current flowing through the coil.